Time travel. It's one of the biggest mysteries that have captured humanity's imagination for centuries. What if you could go back to fix your mistakes? Or peek into the future for a quick spoiler alert? Whether you've seen it in movie classics like Back to the Future or have dived into comic book speculation, time travel has always been an enthralling topic. But here's the deal. How real is it? Can modern science support the idea of bending time and space to hop between different points in history? Let's unpack the ultimate question. Is time travel possible? And by the end of this video, I assure you, you'll look at time differently. Let's start with some basic science. Einstein's theory of relativity, which is over 100 years old, explains that time is not a fixed concept. Instead, it's more like a stretchy fabric that can be impacted by speed and gravity. This theory introduced the concept of space-time, a kind of four-dimensional map that fuses the three dimensions of space with the fourth one, time. This blend isn't constant, it can warp and bend. Think of it as a trampoline. The heavier the object, like a bowling ball, the more it bends the surface. Here's where things get juicy. Theoretically, if you travel close to the speed of light, a staggering 186,000 miles per second, time for you would slow down relative to someone standing still. This is called time dilation. Remember the movie Interstellar? In one scene, characters visited a planet close to a supermassive black hole. Hours they spent there amounted to years on Earth. That's time dilation in action. But hold on. What about traveling backward in time? That's where it gets even messier. Reversing time would mean playing with causality, the always forward direction of cause and effect as we know it. Imagine you went back in time and accidentally prevented your grandparents from meeting. Would you even exist in the first place to make the trip? This is what scientists call the grandfather paradox. It's one of many logical headaches when we think about backward time travel. Now, theories like wormholes come into play. These are shortcuts through space-time often predicted by Einstein's equations. Imagine folding a paper, where one edge represents the past and the other the future. By punching a hole in the paper, you create a shortcut, connecting the two ends directly. Theoretically, one could traverse time by going through such a wormhole. But there's one major problem. It's a solution that exists only on paper. Current technology and our understanding of physics suggest creating such a wormhole, let alone stabilizing it, would require an insane amount of energy. And I mean insane. It's mind-bendingly beyond what's practically plausible right now. You might wonder, if time travel is impossible, then why do scientists keep pursuing the concept? The answer is simple. Unexpected discoveries often come out of chasing wild ideas. For instance, studying time travel may lead to breakthroughs in quantum physics or even understanding the universe's ultimate fabric. Speaking of quantum mechanics, let's dive into the concept of quantum entanglement. It's an area where science begins to feel a lot like magic. Think of time travel on an ultra-small scale, particles communicating faster than the speed of light, seemingly across different points in time. Some researchers believe that quantum mechanics might hold the secret to solving time travel puzzles on a macroscopic scale. Wait, does this mean we're inching closer to building a time machine? Well, there's something else to consider. The laws of thermodynamics. According to one of these laws, entropy, or disorder, in a closed system will always increase over time. This aligns with the arrow of time theory. As much as we'd like to rewind, the increasing disorder in the universe serves as a block, a sort of cosmic one-way street. But let's not get completely disheartened. One fascinating experiment called the delayed choice quantum eraser creates scenarios where it almost feels like choices made in the present influence events in the past. While this operates on a quantum scale, it demonstrates how our sense of time may not be as straightforward as we think. There's even speculation that our concept of time doesn't exist at all and is merely a construct of human perception. All right, history buffs, here's a twist. Time travel isn't just a modern obsession. Ancient philosophies, from Hinduism to ancient Greek myths, often featured time manipulation elements. For example, the Hindu text Mahabharata describes a king who travels to the heavens and returns to find centuries passed on Earth. This shows how deeply ingrained the idea of traversing time is in human culture. Let me throw you a relatable thought experiment. Imagine it's 100 years into the future, and someone invents a time machine. Wouldn't we, in 2023, have already noticed travelers from the future walking among us, spilling spoilers? Some probe this mystery through the time traveler paradox, pointing out the total lack of convincing evidence of visitors from forthcoming centuries. If time travel were real, shouldn't someone have shown up by now? And yet, there are tales and conspiracies, like that of John Titor. In the early 2000s, a man claiming to be a time traveler from the year 2036 popped up on internet forums. He offered distressing predictions about the future. While there's no proof he was legitimate, cases like this one keep the idea intriguing. Jumping back to science for a moment, there's one more candidate: the concept of closed time-like curves, CTCs. According to some hypotheses, loops in space-time might allow objects to circle back in time without breaching causality laws. Mind-blowing, right? However, working examples of CTCs exist only in mathematical models, and translating them into practice is still light years away, even if it's possible at all. To wrap this up, the science of time travel is a conundrum wrapped inside a paradox and baked into a mystery. Could it ever become reality? Maybe. But for now, our best bet is to keep an open mind while diving deeper into the strange yet fascinating nature of time itself. Time, as it turns out, may be one of the most mysterious dimensions we'll ever attempt to understand. If this video blew your mind, or even twisted it just a little, don't forget to hit like, share, and subscribe for more episodes of Scientific Facts. Until next time, stay curious, stay questioning, and never stop wondering. Bye for now.